Hi, my name is Alexander Knopp, and this is Introduction to Mathematical Logic. In the previous part of the course, we discussed a simple model for proofs, which is called propositional logic. In this video, we start a new topic. It's called predicate logic. And in this first video, we are going to discuss predicate formulas. In other words, how to formalize statements in the predicate logic. In the predicate logic, we extend the previous system by allowing to use relations, functions, and quantifiers. For example, let's consider these three formulas and try to understand what are the complications and how can we do this. Let's consider the first formula. And note that we have two undefined symbols here. We don't know what it means m and what it means r. Obviously, m should be a set and r should be a relation. And depending how we define these two objects, this formula may be a true or false. For example, if m is a set of positive integers and r of x, y is x is less than y, this formula is obviously true because for every element there is a bigger element. But if m is still the set of positive integers, but r of x, y is y is less than x, it's not true because there is nothing less than 1. So if x is 1, this is obviously false. Okay, the second formula is true whenever we define m and r. And finally, the third formula is always false because this is the negation of this, so they together gives you a contradiction. In other words, in order to define predicate formulas, we need to define what kind of symbols we can use inside, what kind of symbol for relations, symbol for sets or functions. And we also need to define what these symbols mean. And in the predicate logic, we separate these two definitions. The definition of a set of symbols we use is called the signature. And the definition of what they mean is called structure. First, we need to define signature. So consider this formula. It says that for all x exists y such that r of f of x, y is true. Note that we dropped that x belongs to m and y belongs to m because we'll assume that all the quantifiers are over some fixed set, which will be defined in the structure. So right now we write all the formulas with quantifiers without the restriction over this of the set. And in order to define the signature of this formula, we need to define the set of all the relation symbols, the symbols for relations. In this case, there is only one symbol for the relation, it's r. We need to define the set of all symbols for functions. In this case, we have only one symbol for the function, f, this. And we also need to say how many arguments do these relations and functions take. For example, r can take 2 arguments. So the third parameter of the signature says that r has 2 parameters. And f has only 1 parameter, so this third part of the signature said that f has 1 parameter. In other words, signature consists of 3 elements: a set of relation symbols, a set of functional symbols, and finally, an arity function saying that what are the arities of relations and functions we can use. Now we may define predicate formulas. First, we need to define is the notion of a term. For example, in this formula, f of x is a term and y is a term. Let's do this. So let S1, S2, A be a signature. For example, it's something like this. Then term is either a variable. For example, y here is a term and x here is a term. Or it's f of t1 t a of f, where t1 t a of f are terms. So you should remember that the function should take a of f arguments, so we need at least a of f terms. And for example, here f has one argument, and x is a term, so f of x is also a term. And finally, when we define terms, we can define formulas. So predicate formula is either r of t1 t a of r. So it's a relation of some terms. For example, here, this is a formula because it's a relation of one term and another one. Or it can be negation of psi, where psi is a formula. It can be also psi1 sharp psi2, where psi sharp is and or implication, and psi1, psi2 are formulas. And finally, it can be also a predicate and a formula. So it can be exists x psi of x. Psi of x means that the formula depends on x. Or it can be for all x psi of x. Now we are ready to define the structure, in other words, how to interpret the formula, how to compute the value of it. First part of this is the set M, which is saying over which set all the quantifiers are taken. So structure consists of the set M, which is called domain, it also needs to give an interpretation to every relation symbol and every functional symbol. So it also has a function I interpreting all the relation symbols and all the functional symbols. For example, we can consider the following examples of structures for this signature. We can consider domain consisting of positive integers, and we interpret, in the first case, we interpret r as less, and in the second case, we interpret r as greater. And in both cases, we can interpret f to be an identity function. Note that these two structures give two different interpretations to this formula. In the first one, the formula is obviously true because, as we mentioned before, for every element there is a bigger element. However, for the second formula, it's not true anymore because there is nothing smaller than 1, so this formula would be false. In this video, we defined predicate formulas. In the next video, we are going to define what it means to prove them and how to modify natural deduction to work with the predicate formulas. If you have any questions, ask them in the comments. See you later.